Okay, this is number 3 on the benchmark 4, or benchmark 5, chapter 4 review sheet. Here's the problem. Two planes A and B are flying horizontally at the same altitude, so that the position of B is southwest of A, and 30 kilometers to the west and 30 kilometers to the south of A. Suppose plane A is flying due west at 23 kilometers per minute. So this is a top view. You're looking like top down, or maybe you're looking straight up, and you can see these planes flying. They're flying at the same altitude. So we're hoping they're not going to crash here. All right. Plane A is going 23 kilometers per minute. Plane B is flying due north at 18 kilometers per minute. Determine graphically in how many minutes the planes are going to be the closest. So what we want to do is write an equation for the distance between the planes. Let's say the planes are here. We want an expression for that distance. Okay? We want to use variables because that distance is not going to stay the same, right? Both these planes are moving. Okay? So I'm going to create a little triangle here. And we know that this distance starts at 30 kilometers, but it's getting shorter. This purple distance was 30 kilometers when we started, okay? But it's getting shorter. How fast is it getting shorter? 23 kilometers per minute, right? It was 30. This distance was 30. This total distance is 30. This distance in black is 23 kilometers every minute. That's how fast the plane is traveling. So what would I do with the 30 and the 23 kilometers per minute? Maybe let me draw this a little bit better here. The distance, the plane's distance is rate times time. So it's 23 kilometers per minute. Let's let x equal number of minutes. So this distance is 23x. This distance is 30. What would be this little purple distance right here?
7.
This is 30. This is 23x. What could I do with those numbers to get this distance? Subtract them, correct. So if this is 30 and this is 23x, this distance right here would be 30 minus 23x. 30 kilometers minus 23 kilometers per minute. Plane B is flying at 18 kilometers per minute. Again, this total length here is 30. This distance here, again, distance is rate times time, is 18 kilometers per minute, so 18x. So what would this little purple distance right here be?
30 minus 18.
30 minus 18x, good. I'm trying to find D, this diagonal distance. Hoping that it won't be 0, because if the distance is ever 0, what's going to happen to the planes?
Go boom.
Go boom, right? Crash. We hope that's not going to happen. So, how can I set up some type of an equation using the purple triangle and to find a distance for D? Pythagorean theorem, yeah. It'd be like a squared plus b squared equals c squared. So, let's start with a d. I'm going to write it like this. Our diagonal, or our distance squared, is going to equal the top leg, 30 minus 23x squared, plus the left leg, 30 minus 18x quantity squared. Okay? And I really want to find distance, not distance squared though, so what should I do next? Square root. Yeah, you cannot square root each piece, you have to square root the entire side. If you square root the left side, you get square root of d squared is just d. The square root of the right side would look like this. Square root of 30 minus 23x quantity squared plus 30 minus 18x quantity squared. This square root cannot cancel off these squares because of this addition sign in the middle. Now I'm trying to find when this distance equation is going to reach a minimum. Okay, I want a minimum for D. If I was going to do this analytically, I would have to do the derivative of this, and then probably do what after that? Find where the derivative would equal what? 0. It'd probably be 0. It could be undefined, but it also could happen at an endpoint. Remember, absolute mins and maxes happen at either endpoints, where the derivative is 0 or derivative is undefined. But this one says determine graphically Doesn't say analytically. So that's good, because that means we can use our graphing calculator. So take out your graphing calculator. All we're going to do is type in that expression, square root, and then another parenthesis, 30 minus 23x, parenthesis, squared, plus, left parenthesis, 30 minus 18x, quantity squared. Notice there's an extra set of parentheses here to make sure that we square root this entire quantity. Let's think about how many minutes, how far is this plane going to fly in 1 minute? It's going 23 kilometers per minute. It's going to go 23 kilometers, isn't it? How about in 2 minutes, how far is it going to fly? 46 kilometers. So, and this is only 30 kilometers to start. So the plane will already be past this point after 2 minutes. So I don't think we, and this one would be too, because this plane's going 18 kilometers per minute. So in 1 minute it goes 18 kilometers. In 2 minutes, how far would it fly? 36 kilometers. So these planes will have already passed this point where they could crash after 2 minutes. So let's set our window from 0 to 2 minutes. We don't really need to consider anything more than 2 minutes, I don't think. So push window, x min is 0, x max is 2 minutes, and then to set our y values, y is going to represent the distance between them. Let's just hit zoom 0, zoom fit. And you can see we have a minimum right here. So if we find that minimum by going second trace, number 3, a little bit to the left of the minimum, push enter, then a little bit to the right of the minimum, push enter, and then back where we think the minimum's at, push enter. And now we have to interpret the results. Draw a little bit of picture here. We've got a graph that comes down like this, back up. We've got an x value of 1.442. If we go out to the nearest hundredth or thousandth. Y coordinate 5.136. Now think about when you type this in. We didn't type D here, did we? What did we type right there? Y. That's my Y1, right? When we type this into our calculator, this was Y sub 1. So that's Y sub 1. What does the Y represent in this problem? Distance. So this is in, what would be our label on that then? Kilometers, yep. Kilometers. And x would be in minutes. So we just found out is that after 1.442 minutes, the planes are going to be at their closest distance, and that closest distance is 5.136 kilometers apart. So we don't really have to worry about them crashing. Any questions about that?